Hey guys, welcome. Here's our complete the square guided notes. So let's get to it. Alright, so first of all, our example problem here is x squared plus 6x plus 7 equals 0. And we are going to try and solve the quadratic, find my zeros or my roots, my solutions, my x-intercepts, whatever you want to call them, by using this method called complete the square. Now, before I start complete the square, check to see if we can x factor. Check to x factor. Okay, so we should always check. We don't know. Maybe this is x factorable. And so we have 7 on top, 6 on the bottom. Do any two numbers multiply to 7 but add to 6? And the answer is no. So if it's not x factorable, we can't solve it that way. So we're going to use this other method called completing the square. So what we actually have to do is we actually have to get the x terms by themselves. So we're going to move the c term. Remember, I'm going to write just real quick at the top, ax squared plus bx plus c equals 0. So we're going to move the c term over there, and then we'll just have these two pieces right here. Okay? So move c term. Okay, so this is going to subtract the 7 on both sides. We're going to get x squared plus 6x. I'm going to leave a space equals negative 7. Okay. Completing the square, what we're trying to do is we're trying to get a perfect square trinomial. Okay? And the way you do that is you go ahead and identify what this term is that would do that, and as long as you add to this side and this side, your equation is going to stay balanced. Okay? So what we're going to do now is we're going to take b divided by 2. So we're going to take b divided by 2 and square it and find that term. Okay, so b, which will be 6, divided by 2, and then squared is going to be 6 divided by 2 is 3 squared, which is going to be 9. So this is the term that I'm going to add to both sides. So find this, the b divided by 2 squared. We're going to add the b divided by 2 squared to both sides. So we're going to get x squared plus 6x plus 9 equals negative 7 plus 9. So here's our two new terms that we just added. Okay. Again, b is this value here, b divided by 2 squared. We're going to add it. Okay. Now we're going to factor this side. Okay. So to factor, we're going to do our x factoring. We'll do that off to the side. And this is going to be 9 and 6. Now the way it should work out is these two numbers should be the exact same. Okay. If we did it right, we should get 3 and 3. And so this is going to actually factor into x plus 3 squared. Remember, I want to get a perfect square trinomial. And on this side, we're going to get negative 7 plus 9, which is going to give me 2. Okay? Now, what's the benefit of this is we have a squared term. I can actually square root both sides. So we are going to now square root both sides. So we're going to get x plus 3 squared equals 2, and we're going to square root them. Okay? And so we get x plus 3 equals plus or minus rad 2. Now rad 2 we can't get a perfect square of, which is okay. And then we're going to subtract, we're going to solve for x. And so we subtract 3, we get x equals negative 3 plus or minus square root 2. And here we get an unusual final answer, but it's negative 3 plus or minus the square root of 2. I can't add negative 3 and subtract negative 3 from rad 2, so this is our final answer. Okay, and we could write it as an ordered pair if we want. It would be negative 3 plus rad 2, comma 0, and it would be negative 3 minus rad 2, comma 0. Let's look at a couple examples. Okay, so first thing, can we x factor? Anything that multiplies 5 and adds to negative 12? Nope. So we're going to move this piece over. I like to draw those little lines because I know I'm going to add in the b over 2 squared. Okay, so this is going to be negative 12 divided by 2 squared, and we're going to get negative 6 squared, which is going to give me 36. So it's going to be positive 36 and positive 36. So this side over here is going to give me 41. Oh, I'm sorry, that's a negative 5. So that's going to give me 31. And then over here, what's going to happen is we're going to get x squared minus 12x plus 36. We should be able to x factor that. And again, we're going to get a negative 6 and a negative 6. They should be the same, so we can get a squared binomial. So it's very important that we end up with a squared binomial. Because then we take the square root of it, and we get x minus 6 equals plus or minus the square root of 31. Again, 31 is not a perfect square. And then we add 6 over, and we get 6 equals plus or minus square root of 31. This is actually 2 answers, not 1. Okay. I want you to try these 3. I'm going to do them right now, but maybe pause the video and try them. If you want to watch another one and then try the last 2, whatever you want, but please do try these. Alright, again, pause the video if you want to try them. I'm going to just walk through each one of these right now. Add the 6 over. And the only reason why I'm adding the 6 over is because there's nothing that's going to make negative 6 and add to negative 4. So I'm going to take our b, so negative 4 divided by 2 and square it. That's going to become positive 4. Add that to both sides, and we get 10. We're going to x factor. Well, it should be negative 2 and negative 2. Make 4 multiplying, but add to negative 4. So we get x minus 2 squared equals 10. Square root both sides. This is going to be x minus 2 equals plus or minus square root 10. Add the 2 over. And there we go. Notice our answers are going to be very often look like they're in this format. The reason why we're not getting whole numbers is because the problem is if we got whole numbers, we'd be able to x factor them in the first place. Number 3. Nothing multiplies to 2 and adds to 6, so we got to move it over. We're going to complete that square, so we're going to take the b divided by 2 and square it. That's going to be 3 squared, which is 9. This is very similar to our example problem. We know this is going to break down to x plus 3 squared, and this is going to equal 7 and square root. X plus 3 equals plus or minus square root 7. So do that plus or minus, and then subtract 3. Okay. This last one here, we're going to divide both sides by 2. If I divide both sides by 2, I'm going to end up with x squared plus 6x. Let's do it by negative 2. That would be even better. We don't have to deal with that negative. Negative 6x, and this is going to become a positive 20 equals 0. Now again, when we factor it, we have to take count of that 0, but when we're solving, we can just divide it out because this side's 0. Nothing multiplies to 20 adds to negative 6, so we're going to subtract that over. And we're going to take the b, negative 6 divided by 2, and square it. That's going to give me a positive 9, and a positive 9 over there. This would be negative 3 and negative 3. And this is going to become negative 11. Okay? And then when we square root it, we're in trouble. Can't take the square root of a negative. So we know right here, no solution. So that's our indication that we have no solution. And again, it's because you can't take the square root of a negative. Okay? So hopefully we kind of got through those 4. They're a little tricky. Let's go ahead and flip it over. Okay. These ones are just a practice of multiplying perfect squares, what they look like. Okay. We'll do this one, this side later. I think we've made some good progress so far. All right. Ciao.